Okay, the process of filtration has occurred. We've filtered out water and solutes. That water and solutes we call filtrate, which you could think of as kind of a pre-urine. It enters the proximal convoluted tubule. So what occurs at the proximal convoluted tubule? Well, we have the next two processes occurring. We have reabsorption, which you'll notice the direction. We're taking things from the tubule and moving them back into the bloodstream at the peritubular capillaries. So the proximal convoluted tubule is best known for doing a lot of reabsorption. All right, so we're going to take a bunch of the water that got filtered out and bring it back into the blood. So about 65% of the filtered fluid comes back in at this proximal convoluted tubule. We take all the glucose that might have gotten filtered out of your blood and put it back into the blood. Okay, again, glucose is small, so unfortunately it gets filtered out of your blood, but it's super important because it's blood sugar, right? It's our main source of energy. So we got to put it back into the blood. Same is true with amino acids. They're small, they get filtered, but they're super important. We got to put them back into the bloodstream. So 100% of the glucose and amino acids get reabsorbed right away. Now, the exception is if you have a super high blood sugar level. So if you're a diabetic and your blood sugar is through the roof, you're going to have so much glucose getting filtered out, you don't have the capacity to reabsorb it all. So whatever glucose you can't reabsorb is going to stay in the tubules and end up being found inside urine. All right? So that's why some diabetics who don't properly manage their diabetes and their blood sugar could have glucose in the urine. All right? Other ions get reabsorbed as well, sodium, chloride, and potassium. We start bringing those back into the bloodstream. So again, the blue arrows represent reabsorption. And at the PCT, we do a lot of it. We also do a little bit of secretion. So depending on the blood pH, we might secrete hydrogen ions. So remember, hydrogen ions is the measure of pH. The more of these you have, the more acidic. So if your blood is getting a little too acidic, we secrete the hydrogen ions. Now notice secretion's going the other way. We're taking things out of the blood that maybe didn't get filtered, but we needed them to, and we're putting them into the tubule. We also do that with ammonium ions. Urea and creatinine are waste products. So if some of those wastes didn't get filtered, we can at least secrete them into the tubule. So that's the proximal convoluted tubule. So after that, we enter the descending limb and then the ascending limb. Now, what happens at the descending limb? Well, we do more reabsorption of water. All right, so these arrows represent taking water out of the tubule, putting it back into the bloodstream, about 15%. The ascending limb does the opposite. So it takes solutes, again, sodium, potassium, chloride, maybe bicarbonate, which is a buffer, and we'll put that back into the blood. So again, we're constantly trying to get stuff that got filtered just because they were small. We're putting them back into the bloodstream. Now notice the descending and ascending limb are in essence opposite of one another. The direction the fluid's traveling is opposite, goes down versus up in the loop, and then water versus solutes. All right, so that's the loop of Henle. Next structure is the distal convoluted tubule, so that's right here. What it's known for is a little more reabsorption of water, a little more reabsorption of sodium and chloride. What I want you to remember is that it's the target of parathyroid hormone. So now you got to dig back into your brain when we learned about it in the endocrine system. So recall that parathyroid hormone is produced when you have low blood calcium. And if you have low blood calcium, one thing we could do is tell the kidney, specifically the distal convoluted tubule, that if you see any calcium in the tubule, get it out of there. Put it back into the bloodstream because we are low. We are in dire need of calcium. So parathyroid stimulates the distal convoluted to reabsorb calcium. All right, now we're entering a collecting duct. So here's the collecting duct. Collecting duct can make kind of the final adjustments. Because remember, if you get down to this end, you're urine. And once you're down here, there's not much we can do. So the collecting duct is going to be known for doing three main things. Number one, it's the target of ADH. Number two, it's the target of aldosterone. And then it also can adjust the pH of your blood. So ADH we've heard about before, but remember its main stimulus is when you're dehydrated. And when you're dehydrated, what do you need? You need water to stay in the body. So ADH causes reabsorption of water. So we're going to pull water out of the collecting duct and put it back into the bloodstream. What is aldosterone known for? Well, remember, aldosterone does two different things. One is it reabsorbs sodium, so it's going to do sodium reabsorption, take it out of the collecting duct, put it into your blood. It can also do potassium secretion, but that's only if you have high potassium. So secretion is my green arrow, so it can take potassium out of your blood if it's too high, put it in the collecting duct. Now let's look at pH regulation. So your kidneys can adjust the pH of your blood by moving buffer, bicarbonate, or hydrogen ions. So let's say your blood is becoming acidic. Well, one thing you'll want is more of the buffer. So we can take the buffer out of the tubule, out of the collecting duct, and keep it in the blood. If your blood is acidic, we take the hydrogen ions out of the blood and put it in the tubule. So this explains how the kidney combats acidosis, right? So if your blood is acidic, this is what it does. If your blood is more basic, we don't do as much as this, all right? We'll let some of that buffer go, and we won't secrete as much hydrogen ions, all right? So collecting duct, again, target of ADH, aldosterone, and it helps regulate blood pH. This picture kind of goes through how ADH works. Now this slide is if you don't need ADH. So remember, ADH is only necessary if you're dehydrated. If you're fully hydrated, you don't need it. And you let more water leave your body. And we call that formation of dilute urine. So formation of dilute urine is when your body is fully hydrated. All right, we call that a normal osmolarity. Osmolarity is basically the measure of solutes. If you've got the right amount of solutes compared to water, you're good. You're fully hydrated. You're going to have low ADH, all right, and you're going to leave water in the tubule so you can eliminate the water, right? And your urine is going to be said to be dilute. Dilute urine is that nice clear urine, right? When you're fully hydrated and you look at the toilet and, you know, there's very little yellow in that toilet. That's dilute urine. That means you're pretty fully hydrated and you're letting water just kind of flow through you, all right? But notice what happened. The collecting duct is impermeable to water, meaning it can't come out. It stays in that collecting duct and stays in urine. All right. So formation of dilute urine occurs when you're fully hydrated and you have low ADH. These numbers are osmolarity, by the way. When you have a high number, you have a lot of solutes. When you have a low number like this, you have low solutes, and therefore you're dilute. This drawing is going to explain ADH. Now, there's a lot going on here, so let's not panic. Let's just kind of focus on the most important part, and that's shown right here. So notice that the collecting duct is allowing water to come out of it. All right? And that's because you have ADH forming what's called aquaporin channels. Aquaporin means water pores. So when your body is dehydrated, what happens? Well, you detect that in your hypothalamus. All right, so remember, this is your hypothalamus here. This is a pituitary. Your hypothalamus has osmoreceptors that monitor your osmolarity, basically how hydrated you are. If your osmolarity is high, you are dehydrated. ADH gets produced by your hypothalamus, transports down to the posterior pituitary, and then secreted into the bloodstream. It goes and finds the collecting duct and forms what's known as aquaporin channels. Now, how does water know it needs to go this way? Well, notice the osmolarity down here. The osmolarity down in the medulla or the pyramids is really high, and that pulls the water out of the collecting duct via osmosis. So notice this shows what's known as the osmotic gradient. The deeper down you go in that pyramid, in that medulla, the higher the salt content, and that pulls the water out of the collecting duct. And if you're pulling water out of that collecting duct, your urine becomes highly concentrated. It has a high osmolarity because you're trying to keep that water in the body instead of letting it go out in urine. So that's known as concentrated urine. So that's when you go to the bathroom and you look in the toilet and it's a dark yellow amber color. You know you're dehydrated. But the good news is you're producing ADH and trying to keep as much water as you can in the body. All right? So that's ADH production and its effect on the collecting duct. This is another picture, a little easier to look at, so I kind of kept both of those in there. So notice here's a collecting duct when you're fully, you're dehydrated. All right, it's letting water out. Okay, and it's going towards this high osmolarity in the medulla. How is it coming out? You're making these aquaporin channels. All right, and that allows the water to leave the collecting duct. Here's when you're fully hydrated. You have low ADH. You don't form the water channels. Water stays in the collecting duct, and you form large volume of dilute urine. All right, so this is just giving you a visual of what ADH does when you're dehydrated and what happens when you're fully hydrated. All right, next video we're going to start with this summary. Let you rest a little bit there, and then we're going to come back, do a summary of what we just talked about in this video, and then move on a little bit and cover a few other key concepts.